Yes. Good afternoon, viewers. So today I want us to look at another question testing on logarithms. And in this time we are given a question whether you're supposed to solve the question. And when it means solving, it means we are supposed to find the values of x from this statement. So for us to work out this question, the first thing that we look at is you confirm whether the logarithms are of the same base. And then if you look at this question, the first one is of base x and the second one is of base 10. So what we are supposed to do is to ensure that we convert those bases so that they can be of the common base. In this case, for us to do so, there is something that we refer as the change of the base rule, whereby if you are given log b to base a, this can be written as, if you want to introduce maybe say that the base of 10, but for us, I want us to convert this base x to be base 10 so that we can have base 10 and also base 10. So if you want to introduce base 10 to this kind of logarithm, whereby we have log b to base a and we want to introduce base 10, so this will be equivalent to the logarithm of b to base 10 divided by the logarithm of a to base 10. So this is what we refer as the change of the base rule. So therefore, I want us to convert this section, the log 10 to base x, so that we make it have a base of 10. So what applies in this case, it will be equivalent to, therefore this statement will be log 10 to base x is equal to the logarithm of 10 to base 10 divided by the logarithm of x to base 10. And we all know that a logarithm of a number to the same number to the base of that same number is equivalent to 1. And therefore this part, the numerator will be equivalent to 1 over the log of x to base 10. So therefore we have converted this section, the part which is the denominator here, log 10 to base x, to be equivalent to 1 over log x to base 10. So thereafter, what follows next is that we are going to substitute this part into this statement. So that will make it to be equivalent to 1 divided by, so the whole of log 10 to base x is the statement which we have obtained here. So it will be equivalent to 1 over 1 over log x to base 10. And the whole part of this one is squared. Sorry, you can allow me to remove this one. Then you add log x squared minus 3 is equal to 0. Then from that part, what follows next is that uh, we can solve this region, the part which is inside this bracket, because for us to solve this part, we can do this. We can write this statement. It will be equivalent to 1 divided by 1 over log x to base 10. And what happens is that in such cases, what we do, so when we are dividing with a fraction, we convert it into multiplication by changing this one to be a reciprocal. So this will be equivalent to 1 times the logarithm of x to base 10 divided by 1. And when we do that, what we're going to obtain is that it is equivalent to log x to base 10. So therefore, the entire part, this part which is into the bracket, will be equivalent to log x to base 10. So you can just allow me to that part, so that you have seen what we are supposed to do in that region. So therefore, this part will be equivalent to log x to base 10 squared plus log x squared, sorry, it is base 10 minus 3 is equal to 0. So then from there, we can, this question now looks a bit somehow with something that we can solve by letting, so let, because if you look at log x to base 10 is common in both cases. We have log x to base 10 and also log x to base 10. So we can let this log x to base 10, let log x to base 10 be our y. So if that is the case, what we'll have in the first statement will be y squared. That's log x base 10 squared. So y squared plus. Now this region, this part, we can apply what we refer the law, the power law, whereby in the power law we know that if you are given log b raised to power 2, this can be written as 2 log b. So whereby we take this power and we multiply it before the logarithm. So therefore this part can be converted to be 2 log x to base 10, which happens to be your y. So it will be 2y minus 3 is equal to 0. So then from there, what flows next is that this now quadratic equation, which you can solve by getting the product, the sum, and the factors. So from this statement, our product will be equivalent to -3, and our sum will be equivalent to +2. So two numbers, if you multiply, you get -3, but if you add, you are going to get +2. So the two numbers here are equivalent to -1, they will be equivalent to -1 and 3, correct? So those are the two numbers. When you do the multiplication, it will give you -3, and when you add the two numbers, it will give you a 2. Then from there, what follows next is that now we can substitute the two numbers in this second term, making it to be equivalent to y squared minus y plus 3y minus 3 is equals to 0. So let us factor the two. So if we want to factor those two numbers, it will be equivalent to y into y minus 1 plus, this will be equivalent to 3 into y minus 1 is equal to 0. So from there, we pick the two numbers are the same. This part and this part is the same. So we pick one of it. That will be y minus 1. And then the remaining part is y plus 3. Y plus 3 is also equal to 0. Then we want to proceed from that region. We come to this side. Allow me to wrap this one so that we are able to continue with that section. So if we come to this side, we have two values there, whereby y plus 1 plus y minus 1 and the y plus 3 are equal to 0. So with this statement, it simply means that if you take y minus 1, you equate it to 0, therefore your y will be equivalent to +1. At the same time, if you take your y, you add 3 and equate it to 0, then this means that your y will be equal to -3. But remember, the question was not testing you so that you will find the values of y. What you are looking for is the value of x. So what we'll do is that, remember, there is a region whereby we had written that log x to base 10 will be your y. So let us equate this one back to the two values which we have obtained so that we get the values of x. So from that statement, we have said that log x to base 10 is equals to our y. So the first y is equivalent to 1. So we equate it to 1. So from this statement, using the laws again of indices and the logarithms, you notice that it will be equivalent to 10 raised to power 1 is equals to x. So 10 raised to power 1 is equals to x, meaning that our x is equal to 10. Number 2, we have log x to base 10 is equals to -3. This implies that 10 raised to -3 will be equivalent to your x, meaning that your x will be equal to 1 over 1000, which is equivalent to 0.001. So these are the two values of x which you can possibly work on the get from that question which we have done. So I'm hoping that part will help you.